Hey everybody, today what we're going to be doing is looking at the lesson 3.3a, create and analyze a scatter plot. So what this is going to show us is graphing in the real world context. So far we've looked at linear equations where every point fit on an exact straight line. That's not always the case when we're taking data. So if we were to conduct an experiment and I wanted to see what your guys' test score was based off how much time you studied, it wouldn't line up exactly. So it's not like there's a formula to figure out if you study 5 hours you'll get this grade. It just kind of depends person by person. So we're going to experiment with this idea and see what it looks like in the real world. So first what we need to learn is the difference between a univariate and a bivariate data set. So univariate data is data that represents collections or measurements of one variable. Think of like a unicycle. This root word uni means one. Now bivariate data is data that has two variables. So bivariate means two. Bicycle has two wheels. So bivariate is two variables. So what we're going to do is we're going to read a few scenarios and you guys are going to tell me if it represents a univariate or a bivariate data set. Alright, so let's go and check this out. Lucas conducts an experiment where he records the number of speeding tickets issued in Iron County in a given year along with the average price of gasoline for the same given year. He collects his data from the year 1990 through the year 2015. So he is measuring, we got to determine, are we measuring one or two different things? And in this instance, it is two variables. So this would be a bivariate. Now the reason why it's bivariate is because he issues the number of speeding tickets. So he's first off counting how many speeding tickets, but he's also using it for the average price of gasoline. So if gas was, 5 cents a gallon, something extremely cheap, people might drive really fast because the faster you drive, the more gas you use. But let's say gas was very expensive, like $20 a gallon, people would not want to waste their gas, waste the money by driving fast, so they might drive a lot slower in order to save gas. So you are measuring two things there. Alright, so let's go ahead and look at the next one now. Leia conducts an experiment where she records the height of all the NBA players on the LA Lakers on the 2014 roster. This would be an example of a univariate because we are only taking one thing into consideration, which is the height. That's the only thing we can measure. Now, it's kind of trying to trick us by adding other things. She's talking about a specific team. She's talking about a specific season. But as far as what we are measuring, we are only measuring the height. We're not comparing height to anything else. All right. Adele conducts an experiment where she records the selling price of several homes in the neighborhood. So in Carmel Valley and like Del Mar Heights area, they're building all these new homes. And someone wants to record how much these homes are going for. This is also a univariate because we are only measuring one thing. The only thing we are measuring is the price of several homes. We're not comparing that to anything else. Alright, so let's go ahead and look at this. Lisa conducts an experiment on the number of times a person works out a week and the person's weight. So she's going to be comparing how much someone weighs versus the person's weight. So for instance, maybe if people are more fit, they might weigh less, therefore they might go to the gym more. Versus a person who does not go to the gym and gains a lot of weight, the heavier they are, possibly that they go to the gym less. Now I want you to realize the words I'm using like possibly or probably or things like that nature, because the reason why when we're talking about scatter plots and analyzing data, it's not like a cookie cutter. It's not like a one rule is true for all of them. There are always exceptions to the rule. So now what we're going to look at is how to graph this data, and we're going to use it in the form of scatterplots. Scatterplots are often used to represent bivariate data sets so that the relationship, if any, between the variables is easily seen. So I want you to realize we're going to be focusing on bivariates, which is comparing two different variables. A scatterplot is a graph in which a coordinate plane of the set of x and y ordered pairs that shows the relationship between two sets of data. So let's go ahead and check this out. Jenny is a hairstylist and decides to record the amount of money she makes in tips over a 10-day period. She wonders if the amount she earns in tips is associated with the number of clients she has each day. So remember, a tip is if you go to a hairdresser, they cut your hair, you have to pay for your haircut, but in order to say thank you to the person, you give them a little extra money. That's what a tip is. So if the amount of money she earns in tips is associated with the number of clients, so the number of people she sees, the number of people's hair she cuts each day, she looks back through her appointment book and records the information in the table values below. To better visualize the data, Jenny makes a scatter plot. So really quickly, this is what her book, what her tip book said. This is what she wrote down. This is the number of clients. This is the amount of people's hair she cut down each day. And remember, if you tip someone, it is up to the customer to decide how much you tip. So sometimes customers might tip more or less. This represents how much total she earned. Now, when we're talking about a scatter plot, this is the graph right here to the right that I'm making a little larger. This is an easy visual representation to see that the number of clients she had and the amount of money she got per tips. So what does the point 9, 100 represent? So if I go over here to 9 on my x-axis, which represents the number of clients, and 100, which is this point right here. This represents when she had 9 clients, she earned $100 in tips. So it's it is easy to see what each one of these dots are by following how many clients, going up to that point, and corresponding how many dollars she got on the y-axis. Okay? So now it says, what observation can you make about the scatter plot? So by looking at this, I want you to think about it. Just by looking at it, what can you tell? What general rule can you come up with? So when I look at this, I notice that it's generally going in an upward trend. So if you see this, it's not making a straight exact line, but if I were to add a line here, you guys could see that it's going in a generally upward trend. What this is telling me is the more clients she gets, the more money she is going to earn in tips. So, the more clients she has, the more money she earns in tips. Alright, now there's one point also that doesn't really fit this trend. That is this 3,70. It's a little off the line. So 3,70 does not fit this line. I would say general trend of the line. Now it's close, but it's not exactly, it's not really bunched down lower. It's, hanging out here. All right. So is the amount Jenny earns in tips associated with the number of clients that she has each day? I would say yes, because the general trend is the more clients she has, the more money she earns. Now I want to focus this. Is the amount of money in tips associated? What that means is it related? Do you see a correlation between the two? Is there a pattern between the two? If the dots were all over the place and it looked random, there would not be association. But because there's an upward trend, the more clients she got, the more tips she earned, that is the association. All right. Now, on the 11th day, so really quickly, there's only 10 points on here. So let's say on the 11th day, she had one client and $160. That is this. Plot this point. What is this point called? When you have a point that is nowhere near the general trend, okay? It's just totally off. So this one is close-ish. You can see it's part of it. But this blue point is nowhere near this general trend. It's totally out of the place. What we call this is the point is an outlier of the data. So this point we call an outlier. It means it's totally out of the normal. So if you're ever studying for the test and you have that one kid that says, I never studied and I got 100%, that student is an outlier because he totally does not fit the norm, I would say. This person, if you only get $160 from one client, that is also out of the ordinary, so that would be called an outlier. So let's go and write that down. The point is an outlier of the data. So it doesn't follow the general trend of the data. Alright, so hopefully this introduced an idea of a scatter plot. We're going to pause the video right here. I'd like you guys to go ahead and watch the second video, and we can finish our notes that way.